So, good evening, everyone. So, we come with new set of questions, and the first question is, what are the advantages of using IoT instead of using SCADA and WSN in the industry 4.0? Okay. So, what are the advantages of using IoT instead of using SCADA and WSN in the industry 4.0? So, intro. Industry 4.0 involves smart manufacturing. Okay, Industry 4.0 involve smart manufacturing where everyone. So Industry 4.0 involve a smart manufacturing while machine, sensor and system communicate in real time. Okay, traditional system like SCADA and WSN are very powerful, very useful, but IoT offer more scalability, intelligence and connectivity. Okay, Industry 4.0 involves smart manufacturing where machine, sensor and more scalability and intelligence and connectivity. Okay, advantage of IoT over SCADA. So advantage of IoT over SCADA. So advantage of IoT over SCADA. So cloud-based monitoring system. Advantage of IoT or traditional method SCADA because it provide a cloud-based monitoring system, remote access. Okay, so IoT system are cloud enabled, allowing the control and monitoring from anywhere. So IoT system are cloud enabled, allowing the control and monitoring from anywhere. SCADA is mostly local on premises. Okay, SCADA is locally used, and whereas the IoT is a cloud based that enable the control over enable and allow controls and monitor from anywhere. Okay, high scalability. IoT IoT network can easily expand to the thousands of devices. So our IoT network can easily expand to thousands of devices. Okay, SCADA expansion is expensive and complex. So SCADA expansion is expensive and complex. Okay, you easily expand thousand and hundreds of devices. SCADA expansion is expensive and costly. Okay, real time analytic and the AI. Okay, IoT integrate with the big data. So IoT integrate with the big data, AIML and predictive maintenance. Okay, SCADA only provide a supervisory control with the limited analytics. Okay, IoT integrate with the big data and predictive maintenance, whereas SCADA only provide supervisory control with the limited analytics. Okay, cost effective. IoT use low cost sensor, gateway and internet connectivity. Okay, IoT use low cost sensor, gateway and internet connectivity. Okay, SCADA required expensive PLCs. Okay, RTUS and proprietary software. Okay, cost effective. In IoT use only low cost sensor, gateway and internet connectivities, whereas SCADA required expensive PLCs, RTUs. Okay, RTUs and proprietary software. Okay, proprietary software. Interoperability. IoT support multiple standard like MQ. Interoperability. IoT support can multiple standard like MQ, TTD, COAP, STTP, where SCADA use vendor specific protocol, less flexible. So it is less flexible. Okay, an advantage. So this is the advantage of IoT over SCADA and IoT advantage of IoT over WSN. So in this we have to see the advantage of IoT over WSN. So WSN stand for the wireless sensor network. Okay, so wide internet connectivity. WSN is closed network. Okay, but IoT connect device directly to the internet cloud, enabling the global access. So WSN is a closed networking. Okay, but whereas IoT connect the device directly to the internet and enabling the global access. So wider internet connectivity. Okay, wider internet connectivity. better integration with the IT system. Better integration with the IT system. IoT integrate with the mobile apps. So IoT integrate with the mobile apps, dashboard, okay, dashboard and database. WSN lack the direct application layer integration. So WSN lack the direct application layer integration. Okay. Improve security, better integration with the IT system. So IT provide a dashboard, mobile system, and databases, whereas WSN is the lack of application layer system. Okay, improve security. WSN IoT support TLS, HTTPS, MQTTS encryption, where WSN is limited and often vulnerable. Okay, in security sense, the IoT is better than WSN. Higher data processing things. Data processing IoT support edge computing, cloud computing. Okay, WSN has limited processing due to the node constraint. Okay, due to the node constraint, WSN has a limited processing due to the WSN has a limited processing due to the node constraint. Support for the diverse communication technology. Support for the diverse communication technology. IoT integrate uh, support a diverse communication technology. Wi-Fi, BLE, Zigbee, NB-IoT, LoRa, 5G. So WSN instant mostly relies on Zigbee like mesh only. Okay, WSN mostly relies on Zigbee like mesh network only. Okay, so we see that the difference between and why we use IoT instead on the advantage of IoT over SCADA. So because the if we see on the cloud-based monitoring, or remote accessing, IoT are the cloud enable and allow control and monitoring everywhere. But SCADA is mostly local and the scalability content can easily be expanded to thousands of devices, and SCADA's expansion is expensive and complex. Real-time data analytics and AI. So IoT integrate with the big data and AI MLs, whereas SCADA only provide a supervisory control with limited analytics, cost effective. IoT use low-cost sensors, gateway, internet connectivity, where SCADA required the expensive PLS or RTUs and proprietary software. Interoperability. IoT support multiple standard MQTT, COAP, okay, HTTP. SCADA use vendor specific protocols, less flexible. Okay, and the advantage of IoT over WSN. So wider internet connectivity. WSN, okay, WSN wireless sensor network is local. Okay, IoT connect device directly to the internet and cloud, enabling the global access. Better integration with the IT system. IoT integrate with the mobile apps dashboard. This one. WSN lack different application layer integration. Okay. Improved security. IoT support TLS, HTTPS, MQTTS, and encryption. WSN security is limited and often vulnerable. Okay. Higher data processing capability. IoT support edge computing, cloud computing, where WSN has a limited processor due to the node constraint. Support diverse communication system. It only support Zigbee or mesh like things. So in conclusion, I have to say that IoT provide better connectivity, intelligence, scalability, and cloud integration. Better connectivity, intelligence, scalability, and cloud integration, making it more suitable for the Industry 4.0 as compared to the traditional SCADA and limited WSN system. So let's move let's move for the next question. Why BLE has a higher data rate than a Zigbee? Why BLE has a high data rate than Zigbee? So let's see. BLE, both BLE, Bluetooth Low Energy, and Zigbee are low power wireless communication technology used in IoT. So both BLE, Bluetooth Low Energy, and the Zigbee is low power communication technology used in the IoT. Okay. However, Bluetooth Low Energy offers significantly higher data rate as compared to the Zigbee due to difference in modulation, bandwidth, and channel design. The different modulation, bandwidth, and channel design. Okay, the reason why the BLE has higher data rate than Zigbee. First of all, modulation, bandwidth, and data rate. What is modulation, bandwidth, and channel design? Okay, modulation, bandwidth, and channel design. These are the differences. And reason why BLE has a higher data rate than a Zigbee. So a larger channel bandwidth. BLE channel bandwidth. The channel bandwidth is 2 megahertz. So Zigbee channel bandwidth. So larger channel bandwidth. BLE channel bandwidth is 2 megahertz. Is No, Zigbee use only 2 megahertz spacing, but actual data channel is just 5 megahertz. Correct comparison. Zigbee operate at 2.4 mega gigahertz to the 5 gigahertz channel spacing, but actual data rate only is 250 kilohertz because it is simpler modulation. BLE use 2 megahertz wide channel, enabling the faster symbol transmission. Okay, BLE use 2 megahertz wide channel, enabling the faster symbol transmission. So higher bandwidth, more data transmitted per second. So larger bandwidth channel. So BLE have a higher bandwidth as compared to the Zigbee. Zigbee operate at 2.4 gigahertz to 5 megahertz, but the actual data rate is 250 kilohertz for a simpler modulation. A BLE use 2 megahertz wide channel, enabling the faster symbol rate transmission. Okay, first of all, larger channel bandwidth. First one, why this is faster, or this one that more effective modulation scheme. So more effective modulation scheme. So BLE use GFSK, Gaussian frequency shift queuing. The more effective modulation scheme, BLE use GFSK, Gaussian frequency shift for its faster symbol rate. Okay, Zigbee use OQPSK with DSS, which spread the symbol over long chip or stability, not speed. Okay, so BLE use BLE use GFSK, Gaussian frequency shift keying, which is having the faster symbol rate, 2 2 m symbol per second. Okay, whereas in Zigbee it is used orthogonal QPSK, coordinated phase shifting, with the DSS feature, which spread the symbol over a long chip for the stability with not speed. Okay, so BLE spend more bit per second due to the high uh, more bit. Okay, BLE spend more bit per second due to the higher symbol rate. Okay, uh, next, faster physical layer throughput. BLA physical data rate. So BLA 4 is a 1 MB per second. BLA 4 point has a 2 MB per second. Whereas Zigbee physical data rate is 250 kbps max. Okay. So BLE physical layer has 4 to 8 times faster than a Zigbee. Good. Whenever we comparison between the physical layer throughput, in which we see that BLE having the higher data rate as compared to the in BLE we see that 1 MB to 2 MB per second. In Zigbee we simply set at 250 kbps. Okay. And then after we have less overhead and lightweight package structure. BLA are very compact and lower overhead. Zigbee is more complex layer. APSK, okay, application support, network key, Mac, all these things. Higher overhead reduce the effective throughput. BLE transmit usable data more quickly. As compared to this one. High symbol rate in which and 1 to 2 m symbol per second. 62 62 kbps symbol. It's 16 times faster than something, 16 times faster than BLE. So in conclusion, we have to say that BLE achieve higher data rate than Zigbee due to the wide bandwidth, faster modulation scheme, higher symbol rate, and lower protocol overhead. Okay, this make a BLE suitable for the fast data transfer application, whereas Zigbee is optimized for the low power mesh network. Low power mesh network. So once again, we have to see what are the point. First of all, BLE and Zigbee are the low power wireless communication technology used in IoT, and BLE offers significantly higher data rate as compared to Zigbee because due to the modulation, bandwidth, and the channel design. Okay, reason why reason why the BLE has a higher data rate as compared to Zigbee because larger bandwidth, larger channel bandwidth. Okay, so in BLE, the channel bandwidth is 2 megahertz, whereas the Zigbee operator has 2 gigahertz to 5 gigahertz, but the actual data rate is 250 kbps, whereas in BLE 2 MB, one a wide range and have a faster, larger. Second is more efficient modulation scheme. So BLE use GFSK, like Gaussian frequency shift, and with the faster symbol rate, whereas the QPSK use with orthogonal FSK, PQPSK, orthogonal QPSK with Q triple S with the spread symbol for the longer chip for stability, not with the speed. BLE spin more bit per second due to the higher symbol rate. Faster physical layer throughput. BLE physical data rate is faster. If we use BLE 4.x, it has 1 MB per second. When we use BLE 5, so 2 MB per second. But in Zigbee physical layer, data rate is 250 kbps. So BLE is 4 to 8 times faster than the Zigbee. Less overhead. This means that less overhead. BLE packet are very compact and less overhead. But Zigbee is more complex, and because it consists of the APSK, NWK, MAC, large overhead. Higher symbol rate. BLE symbol rate is 1 M symbol per second, 2 M symbol per second. Okay. In conclusion, we can say that BLE achieve higher data rate than Zigbee due to the wide bandwidth, fast modulation scheme, high symbol rate, lower physical overhead. This is make the BLE suitable for the fast data transfer application, whereas application Zigbee is optimized for the lower power mesh technology. Okay. Third question. The third question is that design a smart transportation system using BLE and using design a smart transportation system using employ that following the BLE and NB IoT. Okay. The problem statement is that build a system to support real-time passenger info, vehicle tracking, low power sensor reporting across a city. So high level architecture component on vehicle, high level architecture component, high level architecture components. So high level architecture components what are? So on vehicle subsystem, GPS plus IMU for the location heading, BLE beacon on board the passenger stop interaction. NB IoT is modem for the long range telemetry, position diagnostic. Local microcontroller gateway aggregation sensor. So on vehicle subsystem, the scanner to detect the arriving vehicle and nearby passenger. MB IoT sensor, Q counter, environment and periodic upload. Okay. First on vehicle subsystem, there is an architecture in which GPS, BLE, NBQT, and local microcontroller. In bus stop, we use BLE scanner to detect the arriving time of the bus or nearby passenger, and we use NB IoT sensor for the queue counting and environment for the periodic upload. Okay, and passenger and smartphones. Passenger smartphone BLE app for the proximity based services, board auth real time update, cloud app for the route planning and the alert, cloud app for the route planning and the alert, use internet. Okay, passenger smartphone, cloud backend, NB IoT or MQTT injection layer of telemetry, REST or WebSocket for the mobile app for the dashboard, real time routing engine, ETA prediction. Okay, operation dashboard, live vehicle map, alert, maintenance things, all these things are given. So this is the architecture, this is the high level architecture component. Okay, how barely so this too much. So simply see that the barely short range low power and data, the passenger interaction barely become a broadcast to stop the bus ID, app trigger the arrival notification, ticket counter validation, personalized alert, last mile prediction, phone detect the nearby stop, beacon for the seamless onboarding and the offline caching for the schedule. And we give you long range low power license cellular periodic uplink for the GPS vehicle diagnostic and the occupancy counter to cloud deep indoor, all these things, massive impact. Operational sequence, vehicle send the ambiguity location packet to backend. Okay, and backend compute the ETS push update to the mobile app via the MQTT and WebSocket, and the bus approaches the stop, BLE backend advertise the stop, bus info nearby, passenger receive the immediate arrival of the notice and onboarding permission at stop. NB-IoT sensor update the crowd level and the health. Backend suggests the dispatch adjustment, maintenance alert, and send NB-IoT scheduling spare part triggering automatically. So after doing this advantage, so low latency passenger UX is really reliability, city-wide telemetry, deep of this, cost effective and energy efficient, improved operation. Okay, challenge hand over GPS map, privacy, network congestion, security. So conclusion, we can say that hybrid BLE or NBQT design leverage BLE and low latency local interaction of NB IoT, wide area, low power connectivity, delivering a efficient, scalable, smart transportation system suitable for the urban employment. Okay, so this question is a little bit confusing, but we simply have to design a smart transportation system using BLE. So NB-IoT simply make a long range low power license seller in which we have to connect all the devices. Okay, and passenger and the bus stop, all the things. Whenever the bus reach to the stop, passenger get a notification, and NB-IoT gets the crowd strength health, so update inside the backend, and the further stop are assigned by that using NB-IoT. Okay, so next question is, does BLE support MQTT? So MQTT. So okay, queuing telemetry transport is a lightweight publish subscribe protocol designed for the IP based network. Okay, such as Wi-Fi, Ethernet, 4G, NB-IoT. Whereas Bluetooth, on the other hand, So NBQT is a message queuing telemetry transport, is a lightweight publish subscribe protocol designed for the IP based network, okay, such as Wi-Fi and this one. Whereas Bluetooth low power, on the other hand, is a short range, low power design and low power wireless technology primarily designed for the device to device communication, okay. So this lead to a common question: can BLE directly support MQTT? Let's see. So the main explanation, BLE does not natively support MQTT. Okay, though BLE does not natively support MQTT, MQTT require a transport over TCP because MQTT packet are sent over the persistent TCP connection. Okay, MQTT require transport over TCP IPs because MQTT packet are sent over the persistence IP connection. Okay, a BLE does not use IP, so BLE use GAT. Okay, generic attribute profile, GAT with at attribute protocol, which is not an IP based one. Okay, so BLE does not natively support MQTT because MQTT require a transport over the TCP and IP, and MQTT packet are sent over the persistence TCP connection. Okay, BLE did not use TCP and IP because BLE used GAT and AT. Okay, generic attribute profile and the AT attribute protocol, which is not IP based. Okay, and therefore MQTT cannot directly run over. So MQTT not cannot run directly over BLE like other Wi-Fi or mobile network work. Okay, how MQTT can still be used? How MQTT can still be used with the BLE through gateway? Although BLE cannot run MQTT by itself, but it can still integrate with the MQTT via the gateway devices that support IP. Okay, how we do architecture. So BLE sensor architecture, BLE sensor, smartphone or BLE gateway. BLE send data using a GAT characteristic. Okay, the smartphone and gate cloud. So the phone or the gateway take a BLE data and it repackage that data as a MQTT message and publish to a MQTT broker like Mosquito and AWS IoT. Okay, so BLE device is not speaking. So BLE device is not speaking MQTT. The gateway act as a translator between the BLE and the MQTT cloud server. Okay. The emerging standard and the emerging standard. So some newer technology like BLE mesh or BLE mesh and IPv6 and BLE can allow IP packet over BLE, making MQTT theoretical possible. But these are not widely deployed, and the BLE mesh or IPv6 are make can allow IP packet over the BLE. So it is not widely deployed, requires special framework. Okay, so BLE does not support MQTT. The advantage of using MQTT via gateway is a low power variable portable sensor, low power variable and portable BLE sensor, global cloud connectivity through the MQTT, reduce cost and easily integrated with the platform. So conclusion, we can say that BLE cannot BLE cannot directly use MQTT because it does not support the TCP. However, BLE device can still participate in MQTT based IoT through the intermediate gate, usually smartphone or the edge devices that convert the BLE GRAT or data into the MQTT message for the cloud communication. Okay. So, so let's see. Next question. What change has to be incorporated with the smart healthcare system that they use RFID and BLE and Wi-Fi to generate automatic SMS alert to the doctor and the patient? Patient and and which solving this one, commercial aspect and the aspect for fast designing. Okay. The primary activity of the IoT system, that the Internet of Things, the primary objective of IoT is that the IoT system typically involve the five primary activity that enable the collection, process, and use of the data and data from the connected device. So sensing and data collection, IoT device use the sensor to collect data from the physical environment and temperature and motion, humidity and pressure. For example, a smart thermostat sensing the room temperature, okay, sense collecting the data. Data transmission and communication. The data transmission and communication things happen. Collected data is transmitted to the other device for the central system using the collected data is transmitted to the other device or the central system using communication protocol through the Wi-Fi, Zigbee and MQTT protocols. Okay. And ensure the data transmission. So collected device through the central system using this protocol. Ensure the data flow through this one. Now data is processing things. All the received data is analyzed using edge computing and cloud to extract the useful information. Analyzing the sensor data and detect the anomalies and pattern. Decision making. Based on the process data, the system decide to action a trigger or not. Decision making things. Based on the process data, make system decide to action or not. User interaction, the result insight to the presented by the dashboard apps enabling. Okay, smart monitor control information and decision making. Okay, last question. So are the technology of pillar of IoT used in Mhm. The next question is that the next question is, are the technologies of four pillar of IoT used in deployment of IoT, and if yes, how? Yes, the technology of, so we have to answer yes, the technology of four pillar of IoT is directly used in deployment of IoT system. Okay, so four pillar of IoT is devices, sensing devices. Okay, sensing devices, that means technology use sensor, actuator, RFID, cameras, GPS, embedded devices. Used in deployment, physical devices are installed in to physical device used in deployment. Physical devices are installed for collecting the data for example, temperature sensor in a smartphone, temperature sensor in a smartphone, home, RFID tag in supply chain. So the four pillar and the first pillar is used in the deployment. Here we see that the physical things are installed and collect data. After that, connectivity and network. So Wi-Fi and Zigbee, Wi-Fi, Zigbee, LoRa, 5G, Bluetooth, MQTT, and COAP. Use in deployment. These technology ensure the data collected by device is transmitted to the gateway, cloud server, and other devices for the processing. So these technology ensure that the collected data is transmitted the gateway and cloud server and other server or other device for the processing. Without connectivity, IoT deployment cannot be function. So without connectivity, IoT deployment cannot be function. Okay, where we see the second pillar, connectivity and the network. So sensing, connectivity, and data processing thing. Third one is the data processing things. So data processing thing. So data processing technology, cloud computing, edge computing, big data analytics, and AI/ML algorithm. These are the data processing and computation thing. Okay. Use in deployment. Once the data is collected and transmitted, the processing unit analyze it and generate an insight and detect the pattern and make decision. Once the data is transmitted, the processing unit first of all analyze, generate the insight, design a pattern, make a decision. For example, edge computing in a autonomous car for the edge computing is used in autonomous car for the real-time decision making. Okay, data processing things use in deployment. User interface and application layer. Last one, user interface or application layer. Mobile phone, web dashboard, APIs, and visualization tools. Okay, use in deployment. So processed information is presented to user in the actionable form. For example, smart home app, smart home app controlling the device or dashboard monitoring system. Okay, on smart home app controlling the device and dashboard monitoring in the industrial IoTs. Okay, we can see that our four pillar are used in the deployment. Okay, sensing thing, we use all the sensor, RFID camera, so we install all these to collect the real-time data, temperature, and this through the this one. Connectivity things, mm, connectivity networks, like we use Wi-Fi, Zigbee, this one for the technology ensure that the data is collected from the device and transmitted to gateway and cloud server or other devices for the processing without the connectivity of these things. Okay, data processing and computation. So cloud computing is computing on the big data. So once the data is collected and transmitted, the processing unit analyze it and generate an insight and design pattern, make decision making. Okay. User interface, mobile app, web app, process information is presented to the user in actionable form. So smart home app, control devices, and dashboard for the things. So in short, these four pillars, sensing, connectivity, processing, interface, are not just theoretical. Each pillar has a specific technology and that are essential for deploying the functional IoT. Okay. Without any these pillar technology, they cannot be operate end to end. So okay. So we covered the first section.